Hello everyone and welcome to module 4 of DevOps class. Today we are going to learn about a configuration management system called Puppet. Well, with configuration management, we mean that the systems that we are configuring, the op work, the sysop works that the people do, configure the machines, set up the packages, construct the dependencies, deploy the code, get the nodes running, or replicate the configurations on many multiple machines at one single time. So if you want to do all of these things, you'd be taking help from the configuration management system and DevOps. And there are multiple softwares that fall into this category. One such software is called Puppet. Other ones are Chef, Ansible, Salt. Each one has got their own architectures on which they are based. Puppet and Chef both are based on client-server kind of architecture. So in today's session, we are going to learn about Puppet. From layman's term, I would call Puppet as a mirror and the nodes or the machines that the Puppet manages to be a person. So let's say a person wants to go out of the house and he stands in front of the mirror and asks the mirror that how am I looking? So mirror would give back a feedback. So mirror would say that okay, you are missing a tie. Go put on a tie. So the person goes back, he works on himself, puts on a tie, gets back in front of the mirror and checks himself again. If he is already wearing a tie, he will not try to do so again because he is already in a state in which he should be. Alright? So in that case, the nodes will not be acting on themselves. So here in case of Puppet, let's make one thing very much sure that Puppet does not fire any of the commands on your nodes. Nodes would be responsible for configuring themselves. Puppet is responsible for just holding the data, holding the configuration which should be implemented. So Puppet reduces the work of a sys Sky. Here the Puppet has got client-server kind of architecture where server would be some centralized location, and on the server we would be having a package called as Puppet Master. Okay, and on the node side we would be having multiple nodes, and all of these nodes would be holding a package called as Puppet. Okay, they are called as Puppet agents, but the package which we are going to install is just Puppet. So let me get these nodes here. So we have got node 1, node 2, node 3, and so on. So there would be multiple nodes in your cluster. It could be hundreds of nodes if you want them to be. So node 1 would be requesting the data from Puppet Master. Okay, so Puppet Master is responsible for providing configurations to all of these machines. On the node side, the package that I told you is called Puppet Agent. Okay, and the package name is just Puppet. Here the package name is Puppet Master. So on both the sides, there would be daemons which are taking care of the machines. Puppet Master is responsible for holding the configurations. Puppet Agent or Puppet is responsible for working on the node itself. For any reason, if your network goes down or Puppet Agent crashes or maybe it gets corrupted, then you will not be able to connect back to the Puppet Master. All right, in that case, you would lose a node, or maybe if you already know which node is misbehaving, you could go there and fix it manually. That's a completely different stuff. So here, what we do, how do we connect and how do you configure the nodes via Puppet Master? For that, we have a developer machine. On this developer, we have Puppet Agent installed. Okay, so Puppet Agent can be running on developer machines as well, where we would be writing our manifests, testing them. Now these manifests are actually .pp files, the Puppet parser files, which would be holding singular descriptive blocks. Now these single descriptive blocks are actually called as resources. Every single build unit on a particular machine is called a resource. So in case of Linux, a package could be a resource, a service could be a resource, even a file is a resource, a cron job, an NIC card, your computer's general settings, everything is a resource. And the way we declare it, we simply write a resource name and declare in which state it should be. We don't specify how it should get there. So what I mean is, let's say Puppet Master is holding some manifests and Node has to be installed with Apache 2. So in the manifest on Puppet Master, I would just declare that, okay, I need to have a package Apache 2 installed. How do I install it? Whether I use RPM packages, whether I use Debian packages, whether I use apt-get public repositories or yum public repositories, or simply copy the package there from some third machine. I don't care. Okay, all of these intricacies or implementation details are managed by Puppet Master itself, and the layer that handles this is called Resource Abstraction Layer, or RAL. Even before your agents could talk to Puppet Master, there has to be a handshake, and this handshake um, results in signing of the certificates. So unless and until you have got certificates signed on both these sides, that means on the agent as well as on the Puppet Master, your agents will not be able to talk to Puppet Master. Let's see a general life cycle in Puppet. So left hand side would be your server side, or I would call it as Puppet Master. Okay, and on the right hand side I would call it as just Puppet and agent. Okay, so how it does is, very first the request is initialized by Puppet agent. It is called certificate request. It is initialized by Puppet Master, sorry, Puppet agent. It goes to Puppet Master, and on Puppet Master we sign the certificates. Once the certificate is signed, Puppet Master knows that this is the node that I should be allowing to talk to me. Okay, only after that Puppet agent can talk to Puppet Master. After that, on Puppet agent there is a daemon running. We have already talked of this, right? So the agent which is running there, it is a daemon. Daemon is a background service that keeps on running and has some specific role or activity associated with it. So here the Puppet agent is responsible for triggering a request, triggering the request for getting the manifests or the configurations onto itself, and that happens every 30 minutes by default. You could of course change the duration in which you want this to happen. So here your Puppet agent would be generating a request. Okay, so I would say this is not a certificate request this time. Certificates have been signed. We could call it as config request. So the configuration request, when it is sent over to Puppet Master would be compiling, or let's see, compile the manifest. So Puppet Master would be compiling the manifests. It would send it across. Okay. So after compiling the manifest, it would be compiling it to a intermediate file called catalog. This is actually a JSON file which is sent across the network. While configuration request is generated, Puppet agent also sends a few data. That data is called facts. So facts are sent across the network. So facts come from Puppet agent. They go to Puppet Master using facts. Puppet Master figures out which machine it is, what is the configuration of that machine, and compiles the manifest for it. The end product of compilation is called a catalog. Catalog is sent back to Puppet agent, where the interpreter would interpret the catalog and would start working on itself. Okay, this working is handled by RAL. Now RAL is responsible for execution of any commands on that box or on that particular node. Once RAL starts compiling, so not compiling, executing the catalog files or to the node, it generates some logs. Now these logs are sent across to Puppet Master, and Puppet Master stores the results which are generated from the logs. So Puppet Master would be responsible for gathering all the logs and formulating the results from them. Okay, that's when the complete life cycle finishes. Next time when the request is generated, the request is not generated by for certificate again, it is generated for pulling the configuration request and configuring itself. So if there is a configuration drift, that means there is a change in the state of the machine and the configuration files which are there on Puppet Masters are a bit different. In that case, the delta or the difference in between them is called a configuration drift. In case there is a configuration drift, in that case only Puppet agent would be working on itself and it will work only on that part which is of the status. Anything that is in line will not be worked upon again. Okay, let's say Apache 2 package is already there, so Puppet agent will not try to install it again. And this policy of Puppet is called idempotent policy. If you're already in a state in which you should be, you will be not doing anything at that particular location. So let's see one thing, that how to write the manifests. So Puppet has got its own language. It's called descriptive language. For the descriptive language, Puppet has written its own parser. So we need to understand how the parser would work. We need to understand what are the different building blocks of the language. So it would be getting past it in a few next minutes. Before going or learning this language, what we would be doing is I need a machine to be present. So in today's session, we are not going to spin up any Puppet installation or we are not going to set up any of the nodes. What we are trying to do instead is that I just want a developer machine on which I'm going to install Puppet agent. I'm trying to configure the Puppet agent. My end goal is that the machine should be having uh, package installed, Apache 2 package installed. I need the service to be always running and I need my home page to be set up to hello world. Okay, and for that I would be using Puppet agent or writing a manifest. Now this manifest is actually a bunch of resources placed inside one .pp file. Manifests would always be having .pp extension to them. So let this machine come up. I would show you how to install Puppet agent there, and at the same time we would be writing a manifest. Okay, so the machine is up. Log in into that, get sudo, okay, and install the package. The package for Puppet agent is Puppet apt-get update and apt-get install Puppet. Once that's finished, once that is done, we would be writing the manifests. We'll be taking complex examples henceforth, but in today's session, we would be concentrating on just configuring the developer machine. In tomorrow's session, we would be learning about setting up Puppet. So there are two flavors of Puppet. One is open source flavor, and the one is enterprise. So there are a few differences in between. Commands are exactly the same. The paths would be relatively same, but absolute paths are a bit different. And feature list is extensive when it comes to Puppet Enterprise. With Puppet Open Source, you would be having all black and white screens, CLI access, no fancy stuff, no explicit reporting. There would not be any centralized control system over there. So it's all upon us. So I've got Puppet installed. Once you have Puppet installed, that means Puppet agent installed. If you hit Puppet, it should work. So it says Puppet command actually exists on my machine. So what I'll do is I'll keep the things to very simple. Simple examples first. I would be creating a file. Currently my directory is all empty and I'm creating a file example.pp. There are multiple building blocks, but in today's session we would be concentrating only on setting up a package, service, and getting my home page ready. So let's check what's there on this box. I need I need Apache to be installed, right? So very first get this example.pp file. Remember the extension should be .pp. There are multiple commands in Puppet that we would be learning. Puppet agent, Puppet apply, Puppet cert, Puppet resource, Puppet parser, Puppet nodes, and so on. There are many more. So what is the syntax? Since we are new to Puppet, I don't remember the syntax, right? Uh, Even you wouldn't know the syntax, right? So let's see, if we don't know the syntax, how do we fix that? So there is a command here which is Puppet resource. The syntax is Puppet resource, resource type and resource name. So resource type in my case is package. Resource name, okay, is there any package which is already installed? Yeah, we just installed Puppet, right? So Puppet resource package and Puppet should be giving you a nice output, and that output is actually the syntax that you should be using for writing any of the resource declarations. Same thing with the files. So resource type is file, and the file name, let's consider that to be etc password. Okay, so that's my file name. So here it says that if you need that file to be created again along with some content, you should be writing file etc password, ensure that it is a file, some content, create time, group, permissions, mode is permission actually. Then there is make time, owner, and type. Similarly, for a service, Puppet resource, now service, I don't know any of the service which is running here. Let's try SSH. Okay, so it says service SSH is running, enable is true. Okay, so the syntax is we have got the resource type as the first keyword. So it would be service, then curly braces. So curly braces would be holding all your declaration. Inside the curly braces, very first argument that you would be passing is the name of that particular resource or the resource name. In this case, it is service is the resource type, as such is the resource name. Do not forget the colon, and after colon, you would be placing multiple attributes. If you're not writing any attributes, that means that attribute value would be picked up from the default values which are defined for that particular resource. So let's write one. I'm following the same syntax. I need a package to be installed, so here it goes, package. Okay, package name. What's the package name that we want to install? It's Apache 2. Okay, so this Apache 2, it would work on Debian systems. It would not work on CentOS systems. In the coming sessions, we would see how to make this manifest more flexible, so that we can use the same manifest over multiple operating systems. Here the package is Apache 2, and I want to ensure that it is present. Now present is a keyword here. You could even write the version of it inside of that. So Apache 2, if you know the exact version of Apache 2 that you want to be installing, mention that in that ensured section. Okay, what's next? Let's see if it installs the package. Go save it for installing. For applying the manifest files that you have written, you should be typing in command puppet apply example.pp. So it would apply. So it says compiled catalog for the node in environment production in 0.34 seconds and finished the catalog run. So if that finished, we should be able to see the Apache package installed. Let me check if the configuration files are present. Let's see Apache 2. So the folder exists, that means the package was installed. What if I remove it? So let's remove it manually. Apt-get purge Apache 2. Okay, so we are cleaning up the packages. All right, so the package is off. If you check the service Apache 2 status, it says service does not exist. Even the configuration files would have been, let's see Apache, I'm trying to hit tab, there's nothing present. Apache 2, does not exist. Okay, great. Let's try it again. Puppet, apply, manifest name. In my case, manifest name is example.pp. Hit enter. It says it has compiled the catalog again. It would try to install Apache again on this machine. Finished. It has changed the status of the package from purged to present. We have purged the package earlier. Let's try it again. Service Apache 2 status. Well, I'm checking the service because when we install the package Apache, it automatically installs the service. So that's what I know. Okay, that's why I'm checking for the service. So it says it's running. That means the package is installed. Cool enough. But if I want to very much specify that while restarting the machine, I want the service to be up. I don't want the service to be off. So what do I do? Let's define the service as well. We have not specified how to install Apache. It is handled by the RAL or RAL layer, right? Now let's go to service. Service, ensure that, okay, first service name is Apache 2. Ensure that it is always running, right? And enable that it is, sorry, make sure that it is enabled. Okay, so let's say enable true. Let's check if the syntax is right. Um, for checking the syntax, there is a command. You'll be typing in puppet parser validate and your example.pp. If there is no output, that means there is no error. I want to cross check whether the attributes that I've written are still right. I would be typing in puppet resource service, and the service that we have checked earlier is as such. So it is ensure running enable true. So that's right. Let's open example.pp again. We have defined a package, we have defined a service. All right, so far so good. Let's check it again. Puppet apply example.pp. Now you see that the service is already running. The package is already installed. So it should not be giving us any notice messages apart from compilation. Okay, what's next? I want the home page to be set up. Let's try and set up the home page. Get example.pp. If you remember the file that we have, file resource that you were talking of, it's file should be present at var www html index.html. So this is the default path where the home page actually resides in Apache 2. So now I'm creating a file. Ensure that it's a file, right? So make sure that it is a file, it's not a directory. It takes two values, one is file and the one is directory. Next, ensure that the content that I want inside the file is hello world. Let's keep it for the demo purpose. We will definitely make it dynamic. We will deploy it using Jenkins, but in later part. All right, I want the owner to be www-data, which is Apache user, group to be the same www-data. Again, we want the mode or permissions to be set to 644. All right, what else do we need? Create time, modify time. We don't need to set up that manually. I just need to make sure that it is a file, the content is set. Okay, sounds okay. Let's see whether it would be able to change the file content or not. Currently, if I hit curl localhost, I should be getting a long HTML page. All right. And if we execute puppet apply example.pp and then do curl localhost, it says hello world. Okay. What if I change the file? Let's try it out. So I want to change the file. I'm changing it. I want to change it from hello world to testing changes. So my home page now shows testing changes. So let's say in your company someone has got access to production for debugging purposes, and he has done some debugging, but in the meanwhile he has also messed up with some settings or some files, and he's not sure which ones. But you don't need to worry about it. If you are controlling those files using Puppet and you change something inside of it, next time Puppet execution happens, Puppet apply example.pp, we are trying to execute this manifest again. It should make sure that the file contents are changed to what it were supposed to be. So curl localhost again should not show testing changes, but it should show hello world. There it goes. Okay, nothing fancy until now. We have written a simple manifest. .pp file is actually a manifest in which we have placed um, resources. Every single entity that I have written inside of it, it is actually a resource. We could bundle it up into one single group. That group is going to be a class, and we could reference that class outside it. So I'll show you how to do that. It's called auto loading and bundling all of these things together. So we'll talk of this in the coming sessions. For now, only remember that there are some resources. There are also control structures, case statements are there, variables are there, custom variables, predefined variables. Then there is factor application which helps you in collecting the facts or details about your machine. You would simply hit factor on screen and get all the data. Now this factor command, what it does is it would scan all your system, gather all the data about it, and show it on the screen. During Puppet request, or when Puppet agent requests Puppet master for the catalog, this factor command is executed on the Puppet agent, data is collected, and data is sent back to the Puppet master. Factor result, if you see closely, is it consists of keys and values. Left hand side would be keys, right hand side would be values. So if I want to check which operating system I'm running, I would simply hit factor and then grep pipe space grep and then operating system. Okay, so there are two keys in which operating system word exists. One is called operating system itself, another one is operating system release. So these two keys would be having their values. My operating system is Ubuntu and my operating system release is 14.04. Okay, it also has got some interesting data about the computer, like what is the free memory, swap size, uh, the versions of it, what is the host name of it, what is the FQDN of it, and a lot of stuff. Okay, you can also figure out whether you are running this machine as a virtual machine or not. So that would be is virtual. So let me check. We would be grabbing another keyword here, which is called virtual. So is virtual is true. That means I'm running this machine as a virtual instance. This is not running on a physical box. And the provider which we are using is VirtualBox. Now, depending on this in data center, maybe if your provider is VirtualBox or it is VMware, you would be deciding which particular software has to be installed as utilities on these machines. Whether you want to install VirtualBox guest edition or you want to install VMware guest editions. That depends. Okay, so making these decisions um, can be maybe sorry, making these decisions can be controlled in this configuration file or the manifest files that we have written. Currently we have just declared 3 resources. Okay, nothing more than that. So in coming sessions, what we are going to cover, so let me write it down. In coming session we would be learning about installation of Puppet. It would be open source as well as Enterprise. So both the versions we would be learning. Then we will also see how to set up nodes with Puppet. Okay, so we would be installing Puppet agent on the nodes. Then we would go through the steps. That means signing of certificates, using modules. We'll also see how to use publicly created modules from that means the modules which are created by other people or community which we can use, right? And these modules are kept on Forge, puppetlabs.com. So that's the website where all the modules would be kept. We would be learning about these things in detail in the coming class. All right, so that's from my side for today. I would drop off the call and would see you again at the same time in tomorrow's session. Thank you so much.